Hello everyone. This is our project Hadoop MapReduce tweet analysis. The motivation behind this is to examine the popularity of Indian Premier League 2020 and study cricket fans' behavior on Twitter through big data analysis using the Hadoop framework and MapReduce programming paradigm. Our group members are Lohit Reddy, who will describe about Hadoop, give us an intro. Neeraj will describe about MapReduce algorithm. Harshit Bansal, who will talk about the dataset being used in this project. Jayant Ide, which is myself, I will talk about the coding procedure for the algorithms involved. Sritej Reddy will talk about the results and inferences found out at the end of the project.
Yeah. Hello all, I'm Lohit. Let's see what Hadoop is. The Hadoop software library is a framework that allows for the distributed processing of large data sets across clusters of computers using simple programming models. It is designed to scale up from single servers to thousands of machines, each offering local computation and storage. Rather than rely on hardware to deliver high availability, the library itself is designed to detect and handle failures at the application layer, so delivering a highly available service on top of the cluster of computers, each of which may be prone to failures. Why I need name node and data node? Data node is responsible for storing the actual data in HDFS. When a data node starts up, it announces itself to the name node along with the list of blocks it is responsible for. When the data node is down, it does not affect the availability of data or the cluster. Let's see the communication between name node and the data node. The data node sends information to name node through four major interfaces defined in the data node protocol. The four are data node registration. It sends data node sends the heartbeat. Data node sends the block report and notifies the blocks received as well. If we want to write a MapReduce code, we need to know the interaction between name node and the data node. Our project is on a single node setup. We have only one node in a cluster. Name node and data node are applicable only to one system, and in our case it is tweets chunk portion. Each trunk represents each portion, and the input will be reading line by line, and the chunks are in the form of lines of text.
Thank you, Lohit. Now we're going to learn about MapReduce paradigm. So basically, our project is implemented on MapReduce. So it is important for everyone to understand the basics of MapReduce, like what it does or what is even consists of. MapReduce was introduced to overcome the failures of previously used cluster architecture for storing and mining data, huge data. We have used MapReduce to implement the three queries: tweet length distribution, unique word count, and tweet location distribution. Now, from the first image, we could see the MapReduce data flow, which consists of three phases: map phase, grouping phase, and the reduce phase. Now, what happens in the mapper phase is a big document goes as an input, that the two modules input split and the recorder present in the mapper phase would reduce the document into key value pairs. The input split we have used divides data into 64 MB chunks, which is the default configuration. This data is passed to the record reader, where data is read line by line and key value pairs are generated. This output of the mapper phase is called intermediate output. The second phase is the grouping phase. In this phase, intermediate output goes as input and values for the same key are grouped together. We have used a combiner to implement this. A combiner works like a mini reducer, reduces the amount of data needed to be processed by the reducer. Basically, reduces the workload of the reducer. The output of the grouping phase goes as an input to the reducer phase. Shuffling and sorting of data takes place here, and various operations can be performed on the data. In this example, where we count the number of times each distinct word appears, we perform a addition or simply count operation. Over to my friend Harshit.
Thanks, Neeraj. So let us understand the dataset. The dataset consists of the details, the tweets with hashtag IPL 2020. It has more than 180,000 tweets and there are 13 attributes starting from August 2020. So we took the dataset from Kaggle. It was publicly available for research. We can see here the different attributes. We have user name, which holds the name of the user. We have user location, which holds the location of the user. We have user description, which holds the user-defined description of their account. We have user created, which holds the time and date the account was created. We have user followers, which holds the number of the followers an account currently has. We have user friends, which holds the number of friends. We have user favorites, which holds the number of favorites an account has. We have user verified. So when it is true, it indicates that user has a verified account. Next, we have date, which shows UTC time and date when tweet was created. Next, we have text, shows the actual UTF-8 text of the tweet. Next, we have hashtags, all the hashtags posted in the tweet along with hashtag RTL 2020. Next, we have source, shows the utility used to post the tweet, Android, iPhone, web, etc. And the last we have is retweeted. So it indicates whether this tweet has been retweeted by an authenticated account or not. So as we can see, most of the attributes are categorical and three integer type and two boolean type. So dataset was in CSV format and we used read CSV function called pandas library in Python to import it. And after importing and converting into proper format, the processing was done for searching missing values, handling emojis, removing the delimiter, etc. After it, I worked on researching for the queries that we can perform on the dataset. And in this process, I found some basic inferences like most of the tweets contain various emojis and other hashtags along with hashtag IPL 2020. And since IPL 2020 has wider Indian audience, most of the origin of the tweets was India. And most of the tweets are tweeted using an Android phone, then web app and iPhone. And after referring to the research paper by Ramsey Paul and reading material on Hadoop, I came to the conclusion that text and user location were two main columns we can perform Hadoop MapReduce on, and we can base our queries on these columns. So we decided these three queries: tweet and distribution, frequency of unique words, and user location distribution.
Thank you, Harshit. This is Jayant. My work in this project involved designing the algorithms for MapReduce logic and implementing the code for the three queries run over the IPL 2020 dataset. As mentioned by Harshit before, the queries are tweet length distribution, where each tweet is sorted according to length into 5 character length intervals, as shown here, and the count is found out. Uh, Second query is the unique word count, where each tweet's text is split up into unique words. All the unique words and the count in the entire dataset is found out. The third query is the tweet location distribution, where each tweet's user location field is extracted first, and then the number of tweets originating from a particular location is counted. To help understand the program code flow better. I will explain the logic behind the code for the three queries using simple examples. To begin with, start off with the first query, tweet length distribution. Here, as we receive as input tweet text, whose length is found out using a built-in string function. Each tweet length is compared and segregated into character length intervals like this. So tweet 1 is segregated into the class 130 to 135, tweet 2 into 150 to 145, and so on. The classes or keys are shown in red here, and the value portion is shown in green. So as an example, we have the class here 130 to 135. The next phase of the code moves over to the intermediate combiner phase, which acts as a mini reducer, reducing the workload done at the end by the reducer. This what it basically does is it counts up the it groups keys first and then counts them up before multiple mapper outputs are passed on to the reducer. So as an example, you can see that in this 150 to 155 is the common key, which appears two times, and therefore it is being added up in the combiner phase. The output from many mappers together are grouped by key. This is called the shuffle and sort phase, and then passed on to the reducer as key valueless pairs, where final operation like summation is being performed by the reducer. In this example, we see that the key 130 to 135 and value 1, and key 130 to 135 from mapper 2 and its value 3 are turned into a group by key. So the common key is 130 to 135. The value list is 1, 3 obtained from the two mappers. A summation operation is being formed, and then these two are added up to form 4. We take a look at the next query now. In this, we receive as input tweet text. We have taken 3 tweets as an example here. Each the texts of all the tweets are tokenized using a utility function called string tokenizer. The keys in the mapper are the unique words which occur in these 3 tweets. So line of text are unique words, and the count is mentioned here. Once again, a combiner is being used to find out the each key and their count within the chunk itself. As an example, we see that text appears 2 times here, and so this being combined into one. The output from many mappers together, example mapper 1 and mapper 2 here, are combined together in the group by key phase, where uh, these lists are grouped by key. Line, as you can see here, line is the common key, and 1, 4 is the value list. Once again, reducer performs a summation function on this, and we obtain the final result. Next, we take a look at the third query, which is tweet location. We receive here as input tweet location fields. As you can see here, for tweet 1, it's Hyderabad, tweet 2, Delhi, and so on. The keys in the mapper are locations like Hyderabad, Delhi, England, etc., and the count of their appearance in this chunk. Once again, a combiner is used. In this chunk, Hyderabad appears 2 times, and therefore it is combined within the mapper itself as Hyderabad, 2. The output from multiple mappers are once again grouped by key. So Hyderabad, with Hyderabad being the common key, we only have one value. So value list includes only one element. For Delhi, it's 2, 5, and so on. Summation operation is performed in the reducer again, and we obtain the final result. You can find the code for the project on the GitHub link provided. Also, the 3 queries are based off a program called word count, which is also mentioned in the link here. Thank you.
Thank you, Jayant. So in this part, we will be going through the results and the meaning or interpretation of those results that are obtained through codes, and major most of the interpretation we will be going through is based on the word counts and the frequencies. So going through the first bar graph, it's about most popular entities which we could obtain through the results of unique words. In this bar graph, we could obtain the most popular teams in IPL as CSK or CB, followed by RRMI, um, and we could even obtain the most popular named players, which who are Dhoni and Virat Kohli, and even we could also interpret the most popular matches in IPL, which can be which are shown in bar graph as RCB versus MI, RR versus KXIP. So in the second graph, which is patterns of tweet lengths, uh, it's known that even after firstly there was a restriction on word length, word limit in Twitter, um, as 140 words, but even after changing it to 280, we could observe a we could observe that people are used to the previous word limit, the which is 140 to 150. So that could be the reason why we could see a spike in that region where the 140 to 150 has an abnormal increase in the frequency. And going through the third graph, which is a heat map, in order to represent the popularity of IPL among the locations. The heat map is basically in a way such that we could interpret the popularity based on the color, and that color is basically obtained from the counts of location from the results which we obtained. The red color is representing the low count, which is interpreted as a low popularity among that region, and green regions are primarily the hotspot of popularity of IPL. And it's not just India. We could even obtain this popularity heat map among the in the world countries. The most popular the most popularity is seen in England, which with the 1292 count, and in USA bit uh, a bit less popularity, and followed by UAE, even more even less popularity of IPL. So this is the first part, and in the second part we will be going through the code parts. Thank you.